write down this example because it's very, very difficult to talk about this without is the set of whole numbers closed under addition? Question mark. Is the set of whole numbers closed under addition? And here's what that means, okay? First of all, think of what whole numbers are. What are whole numbers? We talked about it on your list. What were the whole numbers? For example, whole numbers were, Lauren?
0.03.
Whole numbers were all of these numbers here. Okay, they weren't the negative numbers, right? Because those are the integers, that's the next level up. Okay, these are the whole numbers. What it means to be closed is, if something is closed, it means that for every possibility with a set of numbers and the operation, you or your answer will be also in that. Don't criticize my writing. It means that for every possibility with the set of numbers and the operation in your answer, operation, capital, your answer will be also in that set. And this will make no sense until we do some examples that I'll talk to you about it, but I will get write it down. Means that for every possibility with the set of numbers and the operation, your answer will also be in that set. Means nothing till we talk about the example here. The question that is being asked is this. When I look at just the set of whole numbers, if I pick any two numbers and do an addition problem, will my answer also be in that set of whole numbers? And you really can't do this without just picking numbers and trying. For example, if I take 4 plus 5 and I add it together and get 9, is my answer going to be also a whole number? And is that true for every possibility that you can think of? All right, well, 67 plus 4, 71. Is that a whole number? Yes. 99 plus 82. 81. Is that a whole number? Yes. So the answer to this would be yes, it is closed. Because you can't get an answer that's not a whole number when you add two whole numbers together. Okay. Well, what if I changed it to ask, is it closed, are whole numbers closed under subtraction? Okay, now think of some problems there. Well, 8 minus 5. Is 3 a whole number?
Yes.
Yes. But what if I switch them around and do 5 minus 8?
Yeah.
If I can do 5 minus 8, I get a negative 3. Negative 3 is not a whole number, it's an integer. So the answer to this would be no, it is not. It is not closed because I will get some answers that are not whole numbers. By the way, Lucas Spaniel, before I ask you your question here, this is the thing that proves it wrong. That is called a counterexample. If the book asks you or somebody asks you to give a counterexample, that means you just have put down any example that makes whatever statement wrong or false. Lucas.
Can you read the thing in the bottom left?
I will gladly. Means that for every possibility with the set of numbers and the operation, your answer will also be in that set. Let's look at just a couple more. Would real numbers be closed under division? Oh wait, I'm sorry, let's change that. Let's do rational numbers. Would rational numbers be closed under division? Can you divide two rational numbers together and get something that is irrational?
Yes.
Okay, that'd be a counterexample. What would be what, Lucas? What can you divide that?
1.1 divided by 1.1.
1.1 divided by 1.1 is going to be 1, and I'm pretty sure that's going to be a rational number.
Oh. Okay.
First thing you'd have to understand what's an irrational number. Irrational numbers are
Square root of 5.
square roots that don't work out, and
5. Wait, no.
Oh.
and pi. Lucas?
So could it be the square root of 6 divided by
The square root of
2?
6 is not a rational number to begin with.
Divided by,
You have to start, the only two things you can use are rational numbers to do this. What's that?
square root of 4.
Well, the square root of 4 is the same thing as a 2 though. So if you put what, square root of 4 divided by what?
I don't know.
It doesn't matter, because you're always going to get, square root of 4 is just the same as the whole number 2, so it's 2 divided by 8 is 4. So the question is it closed, yes or no?
Yes.
Yeah.
Yes. If you can't think of a counterexample, then you have to say yes. Okay, you have to say yes. Lauren?
What about 22 divided by 7?
Huh?
What about 22?
But that's a fraction.
Yeah, fractions are.
Fractions are rational numbers.
Yeah, but then you do that out, but you get like 5 or something.
What's that? I believe if you do 22 over 7, you'll actually get a repeating decimal eventually. But if you can make a fraction out of something, people, it is a rational number. You cannot make a fraction out of a square root that doesn't work out, and you can't make a fraction out of pi because it's a decimal that never ends. So, Lauren, what you're asking me is 22 over 7, rational number divided by a rational number. It's the fraction 22 over 7. It is a rational number. That's the definition of a rational number. Anything that you can make a fraction out of is actually the definition of a rational number. It gets a little dicey here and there, people, but all right. Here is the deal. Like I said, I don't want to